All right. Welcome to the Deep Dives. You guys have sent in some really cool stuff, and today we're going deep into the world of Aryabhata.
Aryabhata.
A major figure in classical Indian mathematics and astronomy.
Sure.
And he's from the Gupta Empire, right?
That's right, yeah.
So we've got all these articles and stuff, and our mission is to unpack his key contributions.
Okay.
And really why they still matter so much. Like, why is this guy still relevant, you know?
Yeah, I mean, the sources you sent really dive into Aryabhata's life, his work, which is monumental, and the impact he had on math and astronomy. I mean, it's huge. It's not just India, it's global.
Right.
And it's a chance to see how just one person, over 1,500 years ago, could change how we see the cosmos, like even the words we use.
Yeah. No, it's really amazing. So, okay, let's jump into it. He was born in 476 CE.
Okay.
In Kusumapura, which we know today as Patna. It's in Bihar, India.
Mm-hmm.
And this was during the Gupta dynasty, like right smack in the middle of it. And he lived until about 550 CE, so, a good long life. But it's remarkable that we know his birth year so precisely.
Yeah. How we...
It's all thanks to the Aryabhata.
The Aryabhata, okay.
Which is his most famous work.
Right.
It's like you put a little time capsule in there.
So what's in the time capsule that gives us the birth year?
Well, the Aryabhata states that in 499 CE, he was 23 years old.
Oh, okay.
And that 499 CE, that lines up perfectly with 3,600 years into the Kali Yuga.
Oh, wow.
Which is this cyclical era in Hindu cosmology, right?
Right.
So it's like a historical marker embedded in the text. That's why we can be so sure about 476.
Yeah, that's pretty cool that they could, pinpoint it to the year.
Yeah. And there's also this mystery about his origins. Like, where did he come from?
Right.
One source quotes Bhaskara.
Yeah,
and he describes Aryabhata as one belonging to the Ashmaka country.
Oh, interesting.
Yeah, and apparently during the time of the Buddha, some people from Ashmaka, they settled in the region between the Narmada and Godavari rivers.
Okay.
But then there's even this thought that the Ashmaka that's referred to might actually be present-day Kodingalur.
Kodingalur. Where's that?
It's in Kerala. It's like a puzzle,
Mm-hmm. It is like a puzzle. So he's got this possible connection to Ashmaka, which could be this region or maybe this specific place.
Right.
But he ends up in Kusumapura.
Exactly.
So what's the thinking there?
Well, it seems like he probably went to Kusumapura for advanced studies and then stayed there. I mean, Nalanda University was in Pataliputra at the time.
Oh, right.
And some people think, and this is like speculation, that Aryabhata might have headed that institution.
Really? That's interesting. Nalanda was a huge deal.
Huge deal, exactly. And it was the Gupta period. This is a golden age for India.
Right, golden age for science, for math.
Exactly.
So the idea of him being at Nalanda, I mean, it fits, right? It fits with his work.
Totally.
Your sources also mentioned an observatory at the Sun Temple in Tarragona.
Oh, yeah.
Which is in Bihar.
Right.
This suggests he wasn't just theoretical. He was out there observing the sky.
Totally hands-on. And before we go any further, we should probably clear up his name.
Oh, yeah. What do you mean?
It's Aryabhata.
Aryabhata.
Not Aryabhata.
Aryabhata, okay.
No, all the ancient astronomical texts, they use Aryabhata.
Got it.
And Brahmagupta. He even mentions him like 100 times.
Yeah.
Always Aryabhata. Plus, Aryabhata, it messes up the meter in his verses.
Oh, interesting. So it's not just about spelling, it's about the rhythm of the language.
Yeah, exactly. So Aryabhata it is.
All right, Aryabhata. So let's talk about his work, his actual work.
Yeah, okay. So we've got the Aryabhata, right? Which we talked about.
The one that survived.
Yeah, it's his biggest surviving work. It's got math, it's got astronomy, it's a whole package. But we also know about another one, the Aryasatanta.
The Aryasatanta,
yeah.
And that one's lost.
That one's lost, sadly. But we know a little bit about it from other sources, like mentions from other astronomers and mathematicians.
Well, okay. So we have the Aryabhata, that's our main source.
Right.
And then we have these whispers of the Aryasatanta.
Whispers, yeah, exactly.
So what can you tell me about the Aryasatanta?
Well, the Aryabhata uses sunrise for its calculations, right?
Mm-hmm.
But the Aryasatanta, it used midnight.
Oh, interesting. So a different starting point.
Yeah, and it was based on the Surya Siddhanta.
Surya Siddhanta.
Which is an even older text.
Well, I got it.
And it used midnight day reckoning.
Okay.
So it's like a different approach to time and astronomy.
Right.
And here's the really cool part. It described astronomical instruments.
Oh, wow. Like what?
Like the gnomon, which is this tool for measuring shadows.
Oh.
And shadow instruments, angle measuring devices, cylindrical sticks, umbrella-shaped devices, water clocks.
Wow, they had all that back then.
Yeah, that's amazing, right?
That's a whole toolkit.
It is. It's a whole astronomical toolkit. It gives you a sense of how they were observing the sky.
Absolutely. So we have these two big works, and then there's a possibility of a third.
Oh, yeah, right. Al-NTF or Al-Naf.
LNTF? Okay.
This might be an Arabic translation from the 9th century of a lost Sanskrit text.
Oh, wow.
We know about this from Al-Biruni.
Al-Biruni.
He mentioned it as like another piece of the puzzle. Like, how did these ideas travel?
Right. Fascinating. So let's focus on the Aryabhata for a bit. We know it's structured in 4 parts, right?
Yeah, the 4 Pedas.
The 4 Peters, okay.
Chapters. The first one, the Gitikapada.
Gitikapada.
It deals with huge units of time. Kalpa, Manvantara, Yuga.
Okay. So like cosmic timescales.
Huge cosmic timescales.
Yeah.
And there's this table of signs in it.
Oh, interesting.
Yeah, condensed into a single verse.
Wow.
It also mentions planetary revolutions. In a Mahayuga, 4.32 million years.
Wow, 4.32 million years. So he's thinking really, really big.
Big picture stuff.
Yeah.
Then you've got the Ganitapada.
The Ganitapada.
This is the math chapter.
Okay.
Mensuration, areas, volumes, arithmetic and geometric progressions, using the gnomon to calculate shadows.
Okay.
And then it gets really cool. Simple equations, quadratic equations, simultaneous equations,
Wow.
and indeterminate equations. He tackled those with the Kataka method.
Kataka.
Yeah, it's like an early algorithm
Really?
for solving complex equations.
So he was coming up with new ways to solve these problems.
Exactly. Groundbreaking stuff.
Amazing. And then what's next?
Then we've got the Kalakriyapada.
Kalakriyapada.
It's all about timekeeping.
Okay.
Different units of time, planetary positions, intercalary months, Keshai Titus.
Wow, all those time-related concepts.
Yeah, and the 7-day week
7-day week?
with the names we use today.
So he was like figuring out the week.
It's pretty amazing.
Right, that's amazing. So the first 3 chapters are about time, math, and the calendar. What about the last one?
The last one's the Golapada,
Golapada.
and it focuses on the celestial sphere,
Okay.
geometric and trigonometric aspects, the ecliptic, the celestial equator, Earth's shape, day and night, the rising of zodiacal signs.
So he's really mapping out the heavens.
Yeah, it's like a cosmic map.
Wow. What's interesting is how much he covers in the Aryabhata. It's pretty concise, right?
Yeah, it's written in this really terse style, almost like little aphorisms.
Aphorism.
Yeah, like short, pithy sayings.
Okay.
So it needed commentaries.
Like to explain what he meant.
Exactly.
Who wrote those?
His disciple, Bhaskar I,
Laskar I again, yeah.
and Nilakantha Samayaji.
Okay.
They help people really understand the depth of it.
Got it. So to really understand the Aryabhata, you need these commentaries to go with it.
Yeah, like a guidebook.
Right.
Bhaskar, I even called it Ashmakatandra.
Ashmakantana.
Connecting it back to Ashmaka.
Oh, right.
And it was also sometimes called Aryashata's Ashta,
Aryashata's Ashta.
meaning Aryabhata's 108,
Aryabhata's 108. Why 108?
because it has 108 verses.
Oh, I see.
It's pretty cool, right?
Yeah.
Even the name has a story.
Yeah, that's fascinating. So let's talk about some of his mathematical innovations.
Okay.
One that really stands out is the place value system.
Right.
He clearly used it.
Yeah.
Now, he didn't have a symbol for 0, but he could represent powers of 10 without any coefficients,
Right.
which means he understood 0 as a placeholder.
Yeah,
That's huge. That's a game changer.
it is. It revolutionized math. And get this, he didn't use Brahmi numerals.
Brahmi numerals.
The ones we usually associate with ancient India.
Right.
He used letters
Letters.
from the Sanskrit alphabet
Oh, wow.
to represent numbers.
Even for, like, complex calculations.
Yeah, even for his sign table.
That's incredible. So he's continuing this Vedic tradition
Right.
of using letters for numbers.
Exactly. And speaking of big numbers,
Yeah.
he also approximated pi.
Pi, yeah.
And he was so close.
How close?
He got it to 3.1416.
3.1416. Wow.
That's accurate to 2 parts in a million.
That's amazing. For that time period, that's incredible.
And some people even think he knew pi was irrational.
Really?
Based on what? He used the term asana,
Asana.
which means approaching.
Oh, interesting.
like getting closer and closer, but never quite there.
Right.
So he might have had this deep understanding of pi
That's mind-blowing.
and his approximation.
Yeah.
Super influential. After the Aryabhata was translated into Arabic, Al-Khwarizmi even referenced it
Al-Khwarizmi, yeah.
in his book on algebra.
Wow. So Aryabhata's work is traveling across cultures.
Exactly. And in geometry, he gave the correct formula for the area of a triangle.
Okay, the area of a triangle.
The area equals the perpendicular multiplied by half the base.
Right, all right.
It seems basic now, but it was a big deal back then.
Yeah. Yeah, it helped to formalize things.
Exactly. And then there's trigonometry.
Trigonometry.
He laid the groundwork for sines.
Sine, yeah.
Called it Ardjaya,
Ardajia. What's that mean?
half chord.
Half chord, okay.
And it got shortened to Jaya.
That's Jaya.
Then, when Arabic scholars translated his work, it became Jiba,
Jiba.
which, in Arabic writing, they often leave out vowels,
Right.
so it became Ji.
G.
But then that got misinterpreted as jibe,
Jibe.
which means pocket or fold.
Oh, wow.
And then Gerard of Cremona, he translated that into Latin as sinus.
Shyness, okay.
That's where we get sine.
Wow, so sine comes from half chord.
It's an incredible journey.
That's amazing.
And he also worked with cosine, versine, inverse sine.
All those trigonometric functions.
Yeah, and he made the first sine and versine tables, really accurate, with intervals of 3.75 degrees.
Wow, so detailed.
Very detailed. And we can't forget the Kutaka method.
The Kutaka method. Remind me, what was that for again?
Indeterminate equations.
Right.
Remember, those are equations like ax plus by tc.
Okay, yeah.
Where you're trying to find integer solutions.
Right.
It's a problem for a long time. And he came up with this ingenious method called Kutaka,
Kutaka.
which means pulverizing.
Pulverizing.
Breaking it down into small pieces.
Got it.
It's a recursive algorithm, became the standard in India. For a while, algebra was even called Kutaka Ganita.
Kutaka Ganita, algebra based on pulverizing.
Yeah. And there's this example, finding a number that leaves certain remainders when divided by different numbers.
Okay.
The smallest answer is 85.
85, okay.
It shows you how elegant this method is.
Yeah, and it has implications for today, right?
Totally. Cryptography uses this kind of stuff.
Right. Finding integer solutions.
Exactly. And he found formulas for the summation of series of squares and cubes.
Wow. So he's leaving his mark on all these different areas of math.
Huge.
And all of this, and he's also a pioneering astronomer.
Oh, yeah. He had this astronomical system called the Aryabhata system.
Aryabhata system, okay.
Which calculated days from dawn at this theoretical point called Lanka on the equator.
Interesting.
And he had this amazingly accurate understanding of the cosmos.
Like what?
Like he understood the relativity of motion.
Oh, wow.
He said, just as a man in a boat moving forward sees the stationary objects on the shore as moving backward, just so are the stationary stars seen by the people on Earth as moving exactly towards the west.
That's a great way to put it. A really clear analogy.
Yeah, it makes it so understandable.
And that led him to believe that the Earth rotates.
Exactly.
Wow.
He knew the Earth rotates on its axis daily.
That's centuries ahead of most people.
Way ahead. He even calculated the number of Earth's rotations in a yuga.
So he's combining his mathematical skills with his astronomical observations.
Totally. Now, he did describe a geocentric model in the Aryabhata.
A geocentric model, so Earth at the center.
Yeah. The sun and moon, they move on epicycles.
Epicycles, those are like circles within circles.
Yeah, it's how they explained retrograde motion back then.
Right.
And the planets, they have two epicycles, a slow one called Manda and a fast one called Yigra.
Interesting. And what's the order of the planets in his model?
Okay, so from Earth, Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, and then the asterisms.
Okay, so the sun is not the center. But it's interesting that he has Mercury and Venus closer to the sun than Mars.
Yeah. And his model with the epicycles, it's similar to some Greek astronomy.
Like before Ptolemy?
Yeah. But there's this thing called Shikraka. It's the basic planetary period relative to the sun.
Okay.
Some people think this hints at a heliocentric view.
Really? Like the sun at the center?
Yeah. But most scholars agree that his system wasn't explicitly heliocentric.
Right. It's an interesting debate, though.
It is. And he also gave scientific explanations for eclipses. Yeah, solar and lunar eclipses. He rejected those myths about Rahu and Ketu.
Yeah, those demons or whatever.
Exactly. He said the moon and planets shine because of sunlight.
Okay.
And that eclipses are just shadow
Shadows cast by.
by the Earth and the Moon.
Right.
He even talked about the size of the Earth's shadow
Wow.
and how to calculate the eclipse part.
Mm-hmm.
And his calculations, really accurate.
So he's taking these astronomical phenomena and giving them real scientific explanations.
Exactly. And his calculations for the Earth's rotation and the length of the year,
Yeah.
spot on.
How spot on.
He said Earth rotates in 23 hours, 56 minutes, and 4.1 seconds.
Wow.
The modern value is 23.56.4.091.
That's incredibly close.
Incredibly close. And his sidereal year calculation,
Yeah.
365 days, 6 hours, 12 minutes, and 30 seconds.
Wow.
That's off by about 3 minutes and 20 seconds.
That's amazing. I mean, think about the tools he had.
I know, right? It's mind-blowing.
So what kind of legacy did he leave?
A huge one. The Aryabhata became a foundational text in India.
For how long?
For centuries,
Yeah.
it influenced countless scholars.
And it spread beyond India. Right.
Yes. It was translated into Arabic during the Islamic Golden Age,
Okay.
around 820 CE. And that's how his ideas reached a much wider audience,
Like who?
like Al-Khwarizmi and Al-Biruni,
Right? Major figures.
major figures.
Yeah.
Al-Biruni even wrote about Aryabhata's followers believing in Earth's rotation.
So that idea was spreading.
Yeah. And his definitions of sine, cosine, versine, inverse sine, they were fundamental to trigonometry
Right.
and his trigonometric tables. They were used in the Islamic world to make their own astronomical tables.
Oh, wow. So his work is helping to advance science in other parts of the world.
Exactly. And even today, in India,
Right.
his calendric calculations are still used for the Panchangam,
The Panchangam.
the Hindu calendar.
Oh, wow.
And his work also formed the basis for the Jalali calendar.
The Jalali calendar.
Yeah, it was introduced in 1073 CE. Omar Khayyam was involved.
Omar Khayyam, wow.
And versions of that calendar are still used in Iran and Afghanistan.
So his influence stretches over 1,000 years.
More than 1,000 years. It's incredible.
He really is.
And in India, he's a national hero.
Yeah, I bet.
There's Aryabhata Knowledge University in Patna.
Okay.
India's first satellite was named after him.
Wow.
There's a lunar crater named Aryabhata.
Really?
He's on the 2 rupee note.
That's cool.
There's the Aryabhata Research Institute of Observational Sciences near Nainital. The Interschool Aryabhata Maths Competition. There's even a bacteria named Bacillus aryabhata.
Wow, that's a lot of recognition.
It is. He's a big deal.
It's clear that Aryabhata was more than just important to Indian science.
Yeah.
He was crucial to how math and astronomy developed globally.
Totally. I mean, he covered everything. Arithmetic, algebra, trigonometry, astronomy. He calculated the Earth's rotation.
And he did all this so long ago. The accuracy of his findings is just incredible.
It is, especially with the tools he had.
It shows what you can do with observation, logic, and curiosity.
Absolutely.
Yeah.
And that brings us to our final thought for you.
Okay.
Think about this. This guy lived over 1,500 years ago.
Mm-hmm.
Limited tools, limited knowledge.
Right.
But he made these amazing discoveries.
Yeah.
Discoveries that we still rely on today.
It makes you wonder.
It does. What does it tell us about human curiosity?
And the power of the human mind.
Exactly. Something to think about.
Definitely.
Thanks for joining us on the deep dive.
Thanks for having me.